Hello. So just finished the recording of standard graph, and now I'm going to go through um, yeah, I'm going to go through functions. Okay. So I think this will be a quick one. So yeah, let's begin. Okay, so functions I'm gonna explain in the most simplified manner. Okay, it's about transforming one number to another number. Okay, and another number to another number. Okay, so um, I feel that I can cover a lot just by going straight to composite. So I just gonna go straight into that. Okay, so GFX. Okay, so note that right is about putting numbers into some operation, right? Then becoming a new one. And this new one putting into another operation, then becoming another new. Okay, so all your whether the range subset domain all these things, right? Um, it's just a naming. Okay, you just need to know whenever you put a number into another one, you need to satisfy the condition of the domain, the criteria that the criteria that the function can take. Okay, then this new value need to satisfy the criteria of another functions. Okay, so basically what I'm trying to say, right, is that this x, right, firstly have to fit inside here. Okay, so that means the domain of f lah. Okay, then after that, over here, right, your resultant is what? Is certain number, right? So what do we call this? Okay, so now this is range of f already. Okay, so this range, right, need to be able to fit inside. Now this new value you need to transfer into another value. So whenever you put it into a machine, right, you need to satisfy the criteria of the machine. Okay, that's why this thing need to be a subset of the domain of G. Okay, that's it. Okay, that's the criteria for composite. Okay, now let's talk about the domain of this function. Okay, whenever we talk about functions, right, a function, we are always interested in domain or range. That's it. Okay. So the domain of this, right, okay, it refers to the x value that you put in at the very beginning. Okay, so the x value that you put in at the very beginning, right, okay, is also the same as the x value that you put inside f, right? Okay, so the domain of GF is the domain of f. Okay, so just now I said whatever function of interest, right, you will be interested to know the domain of and range. Okay, so the range of this, right, now is tricky. Okay, there is two ways of doing it. Okay, one way, right, is you find your rule of this fg. Okay, say for example x plus 3 over x plus 2. Okay, then because you have your domain of fg already, okay, so let's say domain of fg you do right, is between 2 to infinity lah. Okay, so over here x is more than 2. Okay, so if you have a rule and then you have the x value, right, the range of value of x, right, okay, it's just like a graph kind of question. Okay, that's why I keep saying that your all these topic right need to study as a whole. Okay, so if you know the shape of this, go back to your standard graph. Make sure you watch that video before you watch this. Okay, you're gonna know okay how to draw this graph. Okay, if you know how to draw this graph, then you take the this range onwards, right? X is more than 2, right? You gotta know the y value, the range of the y value, and that will give you the range of GF. Okay, so I can do this with you. X plus 3 over x plus 2 equals to 1 plus 1 over x plus 2. Okay, so over here, it's gonna be like this. Like this. Okay, so your graph gonna look like this, like this. Okay, so we only want the result from here onwards. That's why your range of GF is equals to 1 to infinity. Yeah. Okay, because this is 1. Okay, so that's it. Range of GF is about the y value. Okay, so that's the first way where you know the range of your x and you know the rule, and based on your knowledge in standard graph, you derive the range. Okay, obviously you can also use your calculator, but then sometimes the calculator is not calibrated properly, right? Okay, student will mix up the asymptote to be 0. Okay, but then you realize that this one is not moving. Okay, actually that the asymptote already appears here. Okay, which is your x equals to 1. Okay, that's why I still need you to have the skills to do it organically, and also sometimes all this right, it may not be plus 3, it may be just plus a. Then you need to express the asymptote in terms of algebra, in terms of a. Okay, and that cannot be done by GC. So yeah, you need to learn how to do it organically. Okay, next up we will try the second method of finding the range of GF. Okay, the second method of this right is okay, let's define f and g first. Okay, so let's say which is very difficult. Okay, so we define the rule of f to be x plus 1. Okay, after that g to be x plus 2 over x plus 1. Okay, so you put g inside f, right? It's gonna give you this rule. Okay, but if you want to do it the other way, right? I said before, right? Okay, gfx, right, is about transforming certain value to become another set of value. This another set of value transform again, become another set of value. Okay, and that's your range of gf. Okay, so initially, right here, this thing, right, okay, is from 2 to infinity. Okay, that's the domain of f. Okay, yeah. Okay, as a result, right, your GF, right, this range of values, right, will become 3 to infinity. Okay, so 3 to infinity, right, you are trying to put inside function g. Okay, so it's like you're trying to put inside a range of value of x into a certain y value. So you need to have the graph. Okay, so the graph of this is equals to 1 plus 1 over x plus 1. okay, which is gonna be like this, like this. Just now is negative 2. X equals negative 2. Okay. This one is y equals to 1. X equals to negative 1. Okay. So over here, the like this. Okay. Okay, I think I make some mistake. Yeah, just now I made a mistake of okay, so let's say I change the this one to be x more than negative 2. Okay, then the all this is correct. Okay, so when this one is negative 2, okay, so x more than negative 2, so here initially is between negative 2 to infinity. After that, because this set of values you put inside this x plus 1, okay, is gonna change to negative 1 to infinity. Okay, so taking so okay, Samura, I explain everything again. Okay, okay, so your just now I did something wrongly. Okay, what I did wrongly is that I expressed this thing wrongly lah. Okay, I should put it as x more than minus 2. Okay, that's just how I set the question. Okay, so imagine now the question is set as x is more than negative 2, then um your the when this is the range, right? Okay, what would range of value of x, what would be the range of value of y? Okay, using the graph, we know that the range of value of y will be from 1 to infinity. Okay, next up, uh yeah, because this one is from negative 2 onwards, and domain of GF is based on domain of F. Okay, that's why here is x more than negative 2. Okay, so I say that composite function is about this value becoming another value, becoming another value. Okay, so the first step, negative 2 to infinity, right, is going through this function F. Okay, is gonna become negative 1 to infinity. Okay, after that, the negative 1 to infinity, right, go through function g, right, is not going to be that obvious. Okay, so you will need the graph, okay, of negative 1 to infinity, right? Okay, you pop it into the y, right? Okay, the value you're going to have is this. Okay, that's why the range of fg will be equal to 1 to infinity as well. So both method will give you the same outcome. Okay, I know it's very messy with how I present, so yeah, do jot it down separately and make it neater so that you can understand it better lah. Okay, so with that, I finish composite functions. Okay, next up, I want to talk about inverse function. Okay, so try to recall your memories from your secondary school. Okay, fx, right, equals to something. Okay, say x plus something over something x. Sorry, my how to enlarge. Okay, I don't know. Okay, so maybe here is plus x, okay, and whatever, okay. So you y equals to this thing like that, like that, like that, like that, like that, over like that, okay. And then eventually you swap, then all your x become here, then your y become here. Okay, I don't know how it's gonna look like, okay, something like that. Okay, so then the next step, right, you suddenly uh, y equals to x. You change all the x to y and y to x. Okay, so what's really going on here? Okay, try to imagine this. Okay, if I put 1, I get 2. Okay, if I put 2, I get 3, etc. If I put 3, I get 4. Okay, then after that, for this case, I do the same thing. 1, I get 2, 2, I get 3, 3, I get 4. Okay, so you see, over here, if this one is x, whatever you put value, the value you put here, right, 1 and 2, right? Okay, imagine you just manipulate based on the 1 and 2. Okay, eventually your 1 is still going to be here, your 2 is still going to be here. Understand what I'm saying, right? So for example, 5 equals to 10 over 2, right? Okay, then after that, I try to shift the position of 5 and 10. Okay, so 10 equals to 2 times 5. Okay, that pair, right, should still be the same. Okay, so it's, for example, y equals to x over 2. Okay, then after that, your y equals to x over 2, x equals to 2y. Okay, that values that you put inside here and you put inside here, right, it should still remains with the value you put inside here and you put inside here. Okay, did I do something wrong? I think I did. Okay, so the x and x will still be the x and the y will still be the y. Okay, I hope you understand what I'm saying. Okay, so bunch of algebra, no matter how you shift, that combination of values will still be the same. Okay, so if here is 1, here is 2, right, you reorganize the manipulation, right? Okay, here should still be 1, here should still be 2. Okay, so all these coordinates points, because here is 1, here is 2, right? When here is 2, here is 3, right? Okay, so you swap around, here will still be 2, here will still be 3. When I say swap around, it's manipulate. Okay, so as a result, right, the coordinate pair, right, is still like this. Okay, so now, right, suddenly, because this is y, this is, oh my god, I hope you can see my cursor. Okay, this is y. Okay, then after that, this is y value. Okay, then this is x value, this is x value. Again, then this is y value, this is y value. Okay, after that, right, you suddenly change the y and the x. Okay, you suddenly change the y and the x. As a result, here is still 2, here is still 1, here is still 3, here is still 2. Okay, so as a result, right, now these 2 need to fit the x coordinate position. Now this y, right, need to fit the y coordinate position. Now this x need to fit the x coordinate position. Now this y need to fit the y coordinate position. Okay, and with that, right, we can see that actually, if we were to relate to this changing the rule, the finding f inverse to the graph, okay, it's really the x will become y, the y will become x. You see, 1, 2 become 2, 1, right? 2, 3 become 3, 2. Okay, that's why, okay, this one say is 0, 1, then it become 1, 0. Stuff like that. Okay, then this one what, then become what. Okay, yeah. Okay, so with that, I cover like what really is function. Okay, function is really about the x and y value change, interchange. I can explain it in terms of this kind of context also. So I explained the graph already. I explained the algebra manipulation and coordinates perspective. Okay. Now let's say right, this one is this thing, right? Okay, we undergo through function. Okay. After that, we undergo f inverse. Okay. So the meaning of f inverse, right, is that the thing that is being transformed back to its original one. Okay. So for example, 2, 3, right? Okay. Now this one 3 will become 2. Okay. So initially the x coordinate is before transformation, then y coordinate is after transformation. Okay. Now the x coordinate, right, is before transformation, and the y coordinate is after transformation. Okay. So like this, yeah, because y equal to like that, x so the x is 3 and the y is 2 yeah. So y equal to f bracket x, yeah, okay. So the x is 2 okay, and the y is 3. Okay, so that's the meaning of um, x inverse Okay, now let's talk. So I said that every function, right, you need to know the range and the domain. Okay, so you see, all this value, right, is the same as all this value. Okay, for example, here got 2, 3, 4, 5, etc. Okay, you transform to something else, you transform back, right? Okay, then obviously here will have the same set of values. Okay, so the domain of f, right? Okay, which is all this, right? It's gonna be the same as this. Okay, so the domain of f is equals to the range of f inverse. Okay, and all these things, right, gonna be the same as this. Okay, so the range of f is gonna be the domain of f inverse. Okay, so that's it. So you know intuitively, right? Okay, this need to be the same as what? Okay, the next thing you need to know is okay, be familiar with what is that thing. Okay, whether is it domain or is it range or domain of f inverse or range of f, etc. Okay. Yeah. So what's next? Yeah. So we covered the what's the meaning of f inverse. Then I say that for every function, you need to know the domain and range. Okay. The other thing that I haven't covered about f inverse is validity. Okay. So you see, we always say that it need to be a one-to-one function. But why is that so? Okay. So it's because Going back to the definition of function now, okay, every image, right, okay, can only be mapped into one, every element can only be matched into one image. Okay, so for example, this one become one, right? I cannot split this one into two results. Okay, that is not a function. Okay, understand? That is not a function. Okay, so let's say, right, if we do this, right, okay, we never split any element. Okay, we never split any element, right? So it is still a function. Okay, but if you think about it, right, now we want to do inverse, right? Okay, this one, right, is being split into two and one. Okay, and that violates the property of being a function. Okay, that's why for f inverse to happen, right, the function need to be a one-to-one function. Okay, so one-to-one function, then you use the horizontal test. Yeah. Okay, so okay, talking about the horizontal test, right? Okay, there's a difference between showing is a one-to-one function and is not a one-to-one function. Okay, so yeah, okay, so you see like that, like that, like that, like that, like that. Okay, it's a one-to-one function. Okay, so you need to say that, okay, y equals to k for all values of k. Okay, that means to say, right, okay, be it this one, be it this one, be it this one, be it this one, okay, all of them, right, cut fx at most once. Okay, that means to say your fx curve can stop here. Okay, and this is still a one-to-one function. Okay, that's why it never cut beyond that. Okay, beyond it. Okay, beyond it never cut. Okay, but it's still at most once. Okay, so this thing and capture at all the horizontal line, that concept. Okay, whereas for not a one-to-one function, right? Okay, you just need to prove a particular value, right? Say y equals to 2. Okay, you just need to prove a particular y value that violates the 2x value property. Yeah. Okay, so let's say since this one cut twice can be. Okay, so not one to one. Okay, so it's different. Yeah, and that's kind of ties to the concept of for all and for some. Okay, that one you will rely on it a lot on your vectors. Okay, so we will talk about it when it comes up. Okay, so that's all for this topic on function. The next one will be inequality. See you.